Right, guys. Okay, this is just going through a time of flight question. Okay, because it's something that comes up on almost every single paper, and it's generally quite a difficult thing to do. So I'm going to go through a couple of questions. First one I'm going to go through is this one here. So this is calculate the mass in kg of a single 52 chromium plus ion. Assume that the mass of a 52 chromium ion is the same as that of a 52 Cr atom. So that tells me that the mass that I've got is 52. Now, 52 is in grams per mole. Okay, and I need to convert that into kilograms. So the way in which I'm going to do that is I'm going to take 52, divide it by 1,000, first of all. That's going to give me my mass, okay, in kilograms per mole. Okay, so 0.0052 kilograms per mole. Okay, now the way in which I'm going to get rid of the mole part is I then have to divide it by Avogadro's constant, because as you can see, the unit for Avogadro's constant is 1 over mole. Okay, so if I do that, 0.0052, okay, over L, I'm just going to say L because that's what Avogadro's constant is, that gives me 8.64 times 10 to the minus 26. And that is my mass in kg of a chromium ion. Okay, now the second part of this question then says the time of flight mass spectrometer, the kinetic energy was 1.269. Calculate the velocity of the ion using the equation. So this is my equation here. Okay, my equation's here. I need to rearrange this to calculate what V is equal to, basically. So if I rearrange it, okay, what I get is V equals 2ke over m, and that's square rooted. Okay, so if I rearrange it completely, that's what I'd get. I'm not going to go for the rearrangement because I'm sure you guys know how to do that. Now I just plug in my numbers. So V equals, okay, square root of 2 times 1.269 times 10 to the minus 13, okay, over my m, which I worked out in the question before, 8.64 times 10 to the minus 26, and that's square rooted, and that should give me 1.71 times 10 to the 6, I think, and that's in meters per second. Okay, so that was a simple time of flight question. So the first thing, I think this is the thing that people mainly get stuck on when I've marked the papers, and me and Mr. Bassi have marked the papers. And I think the main thing is that students tend to, or you guys tend to miss out this first part here. I'm just going to highlight it, this part here, of dividing it by 1,000. Okay, if you don't do that, then the rest of your question is going to be wrong. So make sure that you do that, because you've got the mass here in grams per mole, and you need to convert it to kilograms per mole. Okay, so make sure you do that. The second part is then just putting numbers into, rearranging the equation and putting numbers into an equation. Okay, the mark scheme for those two there, so 8.64 times 10 to the minus 26 and 1.71 times 10 to the 6. Okay, right. I'm going to show you another question now. Let's go through this one. Okay, so in this question, says time of flight t of an ion is shown by this equation. In this equation, d is the length, m is the mass, and E is the kinetic energy. The kinetic energy is given as 1.03. The time of flight of a 49 plus ion is that. Calculate the time of flight of a 47 ion. Okay, so in this question, what you will need to do, okay, is first thing is you can work out the distance. So you use what they've given you, the kinetic energy, okay, and the time of flight of the Ti ion. Okay, use that to work out what D is, because those are the things that you have. Okay, so again, I'm going to do it over here. Sorry, just give me one sec. Okay, so time of flight, so I'm going to write it in as it is, 9.816 times 10 to the minus 7 equals D over the mass. The mass is, I want to work out in the same way as I worked out in the first one. So it'll be 49 divided by 1,000 divided by L. Okay, L is Avogadro's constant. And then that is over 2 times the energy, which is this number here, 1.03. So I'm just going to write E because I don't have enough space. So that, if I work that out, and then that will give me a value for, and then I rearrange it to work out what D is, that will give me a value for D. Okay, so D is equal to, I'm just going to check it on here, D is equal to 1.547 Okay, 1.547. Okay, that's my first sort of 2 marks. So I'll put that in there, worked out what D is. Now I can substitute in this D value into that equation, into this equation, to work out my time of flight for 47, for the 47 ion. Just remember also though that you need to change the mass, so that for the question that you just worked out, you use the 49 mass, but for this question now you need to use the 47 mass. So therefore the equation would be this. Okay, the equation would be this: T equals D, which is 1.547, okay, multiplied by the mass, which is 47 divided by 1000, divided by L, remember L is Avogadro's constant, over 2 times 1.013 times 10 to the minus 13. Remember the energy is the same because they both get accelerated to the same speed, essentially. And then that is going to give me an answer of 9.614. 9.614 times 10 to the minus 7. Okay, and that's in seconds. Okay, so again, the same thing, okay, a slightly more difficult question, but the same thing in terms of the mass, okay? And you just have to remember that all the numbers that they give you, so all the numbers that are given to you are in the question. So you just have to identify which numbers are which and know when to put in which number, okay? Any questions, guys? Obviously, come and see me anytime.